Greetings and welcome, friends! Today we're continuing our look at polynomial functions with the remainder theorem. Haha, wonderful. And before we go anywhere, I want to actually start with a bit of a recall. What? Recall? Recall? Recall. Recall. There we go. Let's say I was dividing the following. I should have thought of a problem, but here we go. Let's just do this. What if I was dividing x squared minus 6x plus 7, and I'm dividing that by the following. The following. All right? And let's say I'm dividing it by, I don't know, like x plus 2 or something like that, right? And let's divide this out using, I don't know, maybe synthetic division. That would be cool. How would I set up the synthetic division? Do you guys remember? Negative 2 in the corner.
Yeah. And then you do 1, negative 6, and 7.
I like it, I like it. And then I leave a row and draw this little line. And now I do the classic add, then multiply. Add, then multiply. And add, right? And that's going to be 23, I believe, right? And you guys would be able to translate that, blah, blah, blah. What part of that is the remainder, by the way? The 23, right? In fact, let's actually just label these real quick. I don't know if you left enough room. I probably didn't imply that you needed it. This part would have been the dividend, right? Dividend. This part was the divisor. I always mix those up myself. This guy was the remainder, right? And this part is the quotient. Let's make sure we know those terms, right? So this is synthetic division. You've seen that before, right? Good stuff, good stuff. Let's try the same exact problem using long division, right? Just remember back in the day. Wow, good times. X squared minus 6x plus 7. So I put the, what's this one called? Dividend, right? And this is the divisor. And my, what would be up here? Quotient is where my kind of answer goes. And then the remainder is going to end up popping up down here somewhere, right? So let's long divide this. Do you guys remember how to do that? Divide, multiply, subtract, bring down. Divide x squared by x, I get x. Multiply x times x is x squared. X times 2 is 2x. Subtract step. Oh, this is the tricky one. Don't let it fool you. X squared minus x squared is 0. And negative 6x minus 2x, negative 8x. Yeah. And then bring it around town. Bring it down to 7, right? Bless you. Let's see, next I would divide once again. I'd divide negative 8x by x, and that would give me minus 8. And then do the old multiply step, negative 8x, right? Classic. And multiply by 2 is negative 16. And subtract 7 minus a negative 16 is plus 16. What do I get? 23. Loop to 2. Haha. So this, by the way, once again was the dividend. Dividend, right? This was the divisor. I'll use a capital D. Why not? Bam. And this was the quotient. Quotiente. And this was the remainder, right? Classic. I think we got the same thing, right? This would have been our linear term, so that's the x. This would have been our constant. Oh, subtracting this. Yeah, double negative. Yeah, okay. So it all works out. You guys remember how to do that? Good stuff. Good times. So let's say I want to evaluate a polynomial. All right? Let's just say that we're doing that. I don't know. And let's say that I want to evaluate, let's figure out what is, if I have f of x equals x squared minus 6x plus 7. I don't know, just making this up out of nowhere. No particular reason that I'm picking that right there. I don't know why I would have chosen those values. And let's say I want to evaluate what is f of negative 2. All right. How would you guys have done this last night? You would have used what's called direct substitution. Right? So what would we have done last night? We would have figured out, plug in a negative 2 for all those x's, right? Bam. Negative 2 all squared. Positive 4. We got it. Negative 6 times negative 2 is positive 24. Plus 7. Wait. That is 12. That's what I said. I was worried there for a second there too. Okay, so.
I can't see the
Yeah,
right
sorry. Yeah, it's kind of bright in here. I apologize. So, what does that all add to be? 23. Did we see that anywhere before? 23. 23. 23. 23. Michael Jordan, yeah, represent. His other number, by the way, was 45. Yeah, and he chose 23 because it was quote-unquote half of 45. 22.5 rounded up, apparently.
Cyrus too. Yeah.
No, that was in memory. Because she was
Anyways, so, guys, this is kind of interesting, isn't it?
Yeah, the remainder is the
Yeah, the remainder when doing division by negative 2 into that polynomial is what I get when I input negative 2 in that same polynomial. That, in fact, is the remainder theorem. Wop, wop, wop. So let's write that down. Here we go. The remainder theorem. The remainder theorem. Here we go. Bam. It says if a polynomial f of x is divided by x minus a, the remainder is the constant, I'll write a better H there, f of a. Pretty good stuff, right? So basically that's saying if I wanted to evaluate what f of a is, I could then also do this backwards. I could just divide my polynomial by x minus a. You might wonder, is that really more efficient? And let's do a side-by-side comparison. I'll be back on that in a second. Now, if I do direct substitution, notice I had to do exponentiation. I had to do multiplication. I had to combine, right? And I had to know like sign rules for exponents. I had to PEMDAS this whole thing. I had any number of operations taking place. If I use synthetic division, all I do is add and multiply. Add and multiply. I didn't have to worry about like weird exponential sign rules or PEMDAS or nothing. I was able to get the answer, I would say, easier than this. So that's what we're going to end up doing for a lot of these problems for the rest of this chapter, in fact, is instead of doing direct substitution, we're going to use the remainder theorem in what we'll call synthetic substitution. Wow. But the remainder theorem is actually not done. There's another cool little fact. And, which I think I might have shown you this before. I'll use the words first. The dividend, whoa, timeout. Dividend is equal to the quotient times the divisor plus the remainder. All right, written kind of in our function speak, the dividend is equal to the quotient, if they would call that function q, times the divisor, the x minus a thing, plus the remainder. And what was the remainder? Whatever that is, f of a. All right, so that's kind of a little side fact. And q of x is a polynomial of 1 degree less than f of x, by the way. Is the other thing, but yeah. So that's we've kind of seen that before when we were able to do checks for our division, where I said earlier that when we did a check for something like this, I said if you take your answer and multiply it by that, it should give you this. Specifically, if you included the remainder in it, they say multiply this and then add the remainder, and it'll give you that, and that's the same thing. It all works out. So I just want to point that out. It's kind of the same thing, except this time they're saying the remainder you could actually refer to as f of a if you wanted. Right? F of a is right here. So it's the same thing. They're just building relationships between all that stuff. So let's do I think just one more example might be all we need. Exemple. Here we go. Use synthetic substitution to find, let's say, h of 3. Okay? Now, I was just actually helping someone else out with a little parabola project they were doing regarding projectiles, and they had like this little function that was like, they said h of t, the height of the object, was equal to negative 16 t squared, right? Negative 16 feet per second squared is acceleration due to gravity, t is time, plus, and then they had like their initial velocity was say 74 t, and then plus 5 was like their initial height. I was just helping out one of my advisees with that. So let's say I wanted to figure out how high is this object 3 seconds into launch, all right, whatever this is, whether it's a, rocket, javelin, a rock, slightly less complicated than a rocket. Do you think it's harder to be a rock scientist or a rocket scientist? Probably. I don't know. Geologist, I guess, is what they... if I was a geologist, I'd just call myself a rock scientist. That'd be pretty good. So if I want to figure this out, well, check this out. Let's see, h of 3. So I'm going to synthetically divide by 3 here. All right? And let's see, what am I going to plug in here? Negative 16, 74, and 5. All over. And let's do this. Bring it around town, negative 16, multiply. It's going to be negative, what's that, 48? Did I do that right? And then is this what, 26? When I add those, 3 times 26, that's going to be 60 plus 18, 78. And then add those, 83. So there's my remainder. So what does that mean? Translate that back into function speak. That means h of 3 is equal to 83. Right? That's what that means. And that was way easier than plugging in 83, or sorry, 3 and then squaring it and then multiplying by negative 16 and adding to that 74 times 3 plus, I don't know. You don't have to worry about all the PEMDAS stuff. it all works out. And eventually, we'll actually be even quicker with our synthetic substitution, where we'll just like not even write half of the work. We'll just skip right to the answer, and we'll be awesome. And so if I wanted to talk about this in terms of like projectiles or something, I would say that I could say that 3 seconds into launch, the object is 83 feet high. But I wasn't as concerned about that. For you guys, I'm concerned about, do you understand the idea behind synthetic substitution? Good stuff, good times. So that's the idea. It's nice and easy. So you could check using direct substitution, but I won't even do that because we already practiced that right here. This is direct substitution. Bam. All right. So direct substitution, synthetic substitution. You guys see the difference? Yeah, go synthetic. Also, I want to point out that for synthetic, that what I plug in here, if I'm finding h of 3, it's the same, okay? All right, it's the same as that. That might be worth pointing out.
Is that opposite?
Well, let's look back at the plain old synthetic division, right? If I'm dividing by x plus 2, here it's the opposite.
Yeah.
All right, so you are correct in remembering that. But if you look at the remainder theorem, it says if I'm dividing f of x by x minus a, then it's just f of a. So I'm kind of already taking that into account. So synthetic substitution, it's the same value there. So that's worth pointing out because I could see the temptation to do the opposite. But that's not what we want. So thanks for watching, internet friends. Enjoy synthetic substitution. Bye-bye.